Here we have a SAT math problem. Okay, let's cover the question. P of x equals to x square positive x positive 2 negative 2 times x negative b. In the polynomial P of x defined above, a and b are constants. If P of x is divisible by x negative 1 and x negative 3, what is the value of a? Okay, in the given polynomial function, we have to get the value of this constant a. Actually, there are two unknown constants, a and b, in which we have to get the value of this unknown constant a. Okay, here there is an information, there is a polynomial function P of x is divisible by two linear expressions x negative 1 and x negative 3. So here we can use the remainder theorem to solve this problem. Okay, here we have two divisors x negative 1 and x negative 3 for P of x, and the question says P of x is divisible by these two linear expressions. Since P of x is divisible by these two linear expressions, when I divide P of x by these two linear expressions, the remainder will be 0. So that is what I have to do is I have to equate each divisor to 0 and solve for x. When I equate the first divisor to 0 and solve for x, I am getting x equals to 1. When I equate the second divisor to 0 and solve for x, I am getting x equals to 3. According to the remainder theorem, when the polynomial function P of x is divided by this linear expression x negative 1, to get the remainder, I have to plug in this value of x1 for x over here. So this P of 1 represents a remainder when this polynomial function P of x is divided by x negative 1. Since P of x is divisible by x negative 1, the remainder must be equal to 0. Okay, the same thing we can do for the other divisor x negative 3. That is, when P of x is divided by this linear expression x negative 3, to get the remainder, we have to plug in this value 3 for x over here. Then this P of 3 represents a remainder when P of x is divided by this x negative 3. And since P of x is divisible by x negative 3, the remainder must be equal to 0. Okay, now to get the stuff that is equivalent to P of 1, I have to plug in this 1 for x over here in this expression that we have for P of x. Then I am getting 1 square positive a times 1 positive 2 negative 2 times 1 negative b equals to 0. Here the value of this 1 square is 1, and a times 1 can be written as just a positive 2. Now we can distribute this negative 2 to this 1 and negative b. Then I am getting negative 2 positive 2b equals to 0. Okay, here this positive 2 negative 2 will become 0. We can write a, then we can write positive 2b. We can write this constant 1 over here equals to 0. Now let me consider this is equation number 1. Now we have to do the same thing for this P of 3 equals to 0. So to get the stuff for P of 3, we have to plug in this 3 for x into the given polynomial function. Then I'm getting 3 square positive a times 3 positive 2 negative 2 times 3 negative b equals to 0. Okay, here the value of 3 square is 9, and a times 3 can be written as 3a positive 2, and we can distribute this negative 2 to this 3 and negative b. Then I'm getting negative 6 positive 2b equals to 0. Okay, now we can write this 3a at first, then we can write positive 2b. Now let's combine the numbers 9 positive 2, then we get positive 11. When I combine positive 11 and negative 6, I am getting positive 5 equals to 0. Let me consider this is equation number 2. Okay, according to the question, we have to get the value of the constant a. So for that, what we have to do is we have to solve the system of two equations we have over here. Particularly, we have to eliminate the constant b, so that we'll be able to get the value of the constant a. Okay, how do you have to eliminate the constant b? Here, the coefficient of b in the first equation is positive 2, and the coefficient of b in the second equation is also the same positive 2. When I subtract these two equations, I'll be able to eliminate the constant b. Okay, now let me subtract the second equation from the first equation. Okay, now let me write the first equation as it is. It is a positive 2b positive 1 equals to 0. Since we have negative sign in front of the second equation, we have to multiply each term of the second equation by this negative sign. When I multiply this positive 3a by negative sign, I am getting negative 3a. And when I multiply this positive 2b by negative sign, I am getting negative 2b. Then when I multiply positive 5 by negative sign, I am getting negative 5 equals to 0. Here, this positive 2b, negative 2b will cancel out. When I combine this positive 1a and negative 3a, I am getting negative 2a. And here, when I combine positive 1 and negative 5, I am getting negative 4 equals to 0. Okay, here let me add 4 to both sides of this equation. This negative 4, positive 4 will cancel out. I am getting negative 2a on the left side. On the right side, when I combine 0 and positive 4, I am getting 4. Okay, now let me divide both sides of this equation by negative 2. When I do so, this negative 2 will cancel out. I am getting a on the left side. When I divide 4 by negative 2, I am getting negative 2. Okay, here I got the value of the constant a, that is negative 2. We find this negative 2 in answer choice B. The correct answer choice for this question is B.